What if you want to use the time series tool for light curves other than for Ys or neo-Ys? I do this all the time. So let me give you a real example. I have light curves here from TESS and from ZTF for the same object. So in order for the time series tool to understand that I don't have something from Ys or PTF or ZTF, I have to explicitly tell it other. I've created IPAC table files for all my light curves, and just for ease of working, my IPAC table files just have 2 columns. And since there's only 2 columns and the time series tool understands the heading BJD, it grabs that as the time column. And then the only other column it can possibly grab is titled flux. So it just goes ahead and grabs that as the value of brightness. But here's the first adaptation that I need to make when working with these light curves that technically the time series tool wasn't designed to work for. It just assumes that all of the values are basically in magnitudes. So it puts the bright objects at the bottom rather than at the top. Fine, I can live with that. This one is a ZTF light curve, even though it says flux. It's just the stupidity of my code that generates all of these table files with BJD and flux. It has guessed correctly that these are actually magnitudes and puts the bright objects at the top. But here's an example of something with some pretty big outliers. So I'm gonna filter down that light curve, and then I'm gonna get it moving with a periodogram because it takes a little while to do the periodograms. This one has copious outliers and also an enormous gap in time. So just to make it easier, I'm going to filter down this to get rid of outliers and honestly the first couple of campaigns. I can probably do a better job of getting rid of some of those outliers. Remember that this is inverted compared to what it actually is. So I'm going to get that going. Probably the maximum period is no more than 10 or 20 days for this object. I'm going to go ahead and get that going. Here I have another version of the light curve. This one has a long-term trend, which sometimes confuses a lone scargle. I'm just going to go ahead and let that go again with a maximum period of 20 days. And then for this one, there's very few outliers. Let's go ahead and get that moving again with a maximum period of 20 days. Let's go back to this one. It has a pretty strong peak. That's not crazy. That one probably is. That one probably is. Okay, so 0.59 days is not crazy. That one's not come back yet. That one's come back, but not with any peaks that are really obvious. Let's filter this down so that I can look at the power spectrum a little bit better. See what I'm doing? This is a Firefly table, just like any other table in this tool. But I'm not in love with any of the peaks here, probably because of that long-term trend. It just makes it really hard to find any phases that really work. Now, because of that long-term trend, I could try to remove that long-term trend on the fly because I can come up with a by eye linear fit and then use this to subtract off a linear trend. I've tried that before, not for this star, but for other stars. There's a little bit too much large amplitude fluctuations, but let's see if we can get anything meaningful out of just doing a lone scargle on that relatively flat part. Let's get that moving. That one's not back yet. Is this? No, that one's not back either. Let's go back over here. This one came back because it was just a tiny section. Okay, 1.2 days is not crazy. I think that one is probably the most believable for that flattest portion of that light curve. Let's go check on this. Neither one. Oh, that one's back. Let's see. That's actually looking pretty good. So 4.85 days. Let's see if that works in any of these other. So that was 0.6. This one was 4.8, and that was 1.15. So all of these light curves come back with slightly different periods. Okay, so 4.83 and 4.85. So those two light curve versions, the Spock version and the CDIPS version, are coming back with very similar periods. This one, the Pathos version, is coming up with a pretty different period, but that undoubtedly is because of the long-term trend here. It's making it really difficult to pull out periods. And then ZTF is doing something totally different. So remember, test pixels are huge. I'm wondering if there isn't source confusion going on here. So the next thing that I would need to do, actually, is use the IRSA tool Finder chart to explore the sky at the location of this star and see what other sources could be affecting the test light curves. If the star that is causing the light variations in the test light curve is the same star as the thing that's causing the light curve variations in ZTF. The other thing that we can try, again, because the ZTF light curve has a very long time baseline and the large gaps, let's try reducing the maximum period. And let's try and see if we get any other peaks here. Oh, look at that. Something is still there at 0.5. And there's really nothing prominent around 5 days like the test light curve. So, yeah. So I think source confusion is something we'll need to track down with this particular star. That's my real life example of how I use the time series tool to work with light curves that come from TESS and K2, as well as the light curves it was designed for, ZTF and WISE.